Hello everyone. In this question, we are given that a function fx is equal to the integral of dx upon the product of 3 plus 4x square times the square root of 4 minus 3x square, where the absolute value of x is less than 2 upon root 3. Okay, we are given two additional conditions such that f of 0 is equal to 0 and f of 1 is equal to 1 upon alpha beta times tan inverse of alpha upon beta, okay, where alpha and beta are positive real numbers or positive constants, okay, and we are asked to find the value of alpha square plus beta square. Okay, so before we start, I want to just highlight you the pattern of solving these type of integrals. Okay, this particularly in particular this format. Okay, so this format is basically I'm going to highlight the steps in order to solve this. Okay, this is an integral of the type dx upon, we are given a quadratic term here, ax square plus b say times the square root of another term which contains an x square, right, a quadratic term. So this is ax square plus b times the square root of, say, capital C, this will be small x, right, c x square plus d, right. This is the format of this original integral, right, in abstract. So this is the general procedure. Okay, so whenever an integral of this type is given, the first step is use this substitution of x equal to 1 by t, okay, and also use dx equal to minus dt by t square, right, minus 1 by t square times dt. Okay, this is the first step. Once you do this substitution, this integral changes to, this will now change to an integral of the form minus t dt upon, this x square was associated with a, right, this will now change to a plus b t square. Okay, and this x square inside the square root was associated with this c term. Okay, this will also change now and this will become c plus d t square. Okay, you need some simplification here, but once you do this substitution, these two substitution, this will eventually come to this format. Okay, so once you have this format, you have to use another substitution, you have to use another variable u which is equal to this term. Okay, this term, so you have to use this substitution, u equal to square root of c plus dt square. Okay, or you can also square it and use u square is equal to c plus dt square. Okay, once you do this, this integral will further change to a format of integration of du upon u square, and depending on the sign it will be either plus or minus s square. Okay, now a is a different constant which is different from this any of this a b c d. Okay, this will change after doing the algebraic simplification. Okay, now this is established formula, right, if it is plus here this is tan inverse, and if it is minus here you have this logarithmic formula, right. So in our case I think it will be, since there is f of 1 is tan inverse of alpha upon beta, this will be plus in our case. Okay, so these are the three steps that we need to follow while solving this. This is the general rule. Okay, if any of these questions come in this format, this is the general steps that you need to follow. Okay, so now let us start the integral. Okay, so this is the general procedure. Now we are given f of x is equal to integration of dx by 3 plus 4 x square times square root of 4 minus 3x square. Okay, so again I'll use this first substitution, which is x equal to 1 by t and dx will be equal to minus dt by t square. Okay, so this fx will now change into f of t. Okay, so I'm not writing this fx here, this will now change into a function of t, but in the final answer we need to do the two back substitutions, okay, in order to get back x. So this dx now becomes minus 1 by t square, and this will be 3 plus 4 upon x square will become 1 by t square, so this becomes 3 plus 4 upon t square. Okay, Similarly, the term inside the square root, this changes to 4 minus 3 upon t square times dt. Okay, so this now gives us, this is minus 1 by t square, right? If I take this t square out of the square root, okay, this is inside the square root. In the next step, if I take this t square out of it, we have minus 1 upon t square in the numerator, and if I do the LCM here, this will become 3t square plus 4 divided by t square times, this will be 4 square root of 4 t square minus 3 divided by, I'm taking this t square out of it, so this becomes just t. Okay, so now we can cancel this t square and this t square, and there is a dt left. Okay, so our integral now changes to minus this t is remaining, so this will go in the numerator, right? So this becomes minus t upon 3t square plus 4 times square root of 4 t square minus 3, okay, dt. So you see, this was the original integral, right? So we use the substitution. Now you see that our integral has reduced to this second form. Okay, minus t dt is present here, and the coefficient of t square, which was originally with 4x square, right? This has now become 3t square, and inside the square root also. Okay, it was initially with minus 3, now it is with plus 4. Okay, so this has swapped like this step 2, this step 2. Okay, now we need to use another substitution, which is u equal to this square term. Okay, we will use this substitution. So again, u equal to this square root of 4 t square minus 3. Okay, so using this substitution, we can get u square is equal to 4 t square minus 3. So from here we get t square will be equal to, this minus 3 will come to the left hand side, so this will become u square plus 3 divided by 4. Okay, so this is the substitution for t square, which we might require for this part. Okay, this part has a t square, right? So this is for this part. Okay, and again doing the derivative of this with respect to t. Okay, from here if we do the derivative, we get twice u times du. This will be 8t times dt, right? So we have only t dt, right, in the numerator. So we get t dt will be equal to 2u by 8. So this will become u by 4 du is equal to t dt. Okay, so these are the back substitutions that we have used here. So after doing this, this minus t dt, this changes to minus 1 by 4 u upon 3 t square plus 4, right? So 3 times, this is our t square value, 3 t square plus 4. Okay, this is one term, times this is just u, right? See, this is just u equal to square root of 4 t square minus 3. Okay, so we have u here and we have a du here, so we can cancel this u and this u. Okay, and I'm taking the minus sign out, so we are left with 1 by 4 here, and this on simplification, this becomes 3u square plus 9 plus 4 times 4 will give us 16, right? This is entirely divided upon by 4. Okay, so this 4 and this 4 cancels each other, and this now becomes minus integration of du upon 3u square plus 25, right? So if I take 3 out of here, this changes to minus du upon, if I take 3 common here, this will become u square plus 25 by 3, right? So this now becomes minus 1 by 3 du upon u square plus if I need to make this 25 by 3 as a whole perfect square, I will have to rewrite it as 5 upon root 3 whole square, right? So you see now this has also satisfied this format, right? U square plus a square du by u square plus a square. Okay, so we have already done the 3 steps. Now this is very easy. This is just minus 1 by 3 1 upon a is this one, right? 5 upon 3, so this becomes 1 upon 5 by root 3 tan inverse of x divided by a is nothing but 5 upon root 3 plus c. Okay, so this one further simplification gives us minus 1 by 3 times root 3 by 5 tan inverse of root 3x by 5 plus c. So sorry, I have made a few mistakes here, slight mistakes. This will be u, okay, not x. I have written x here. This will be all u still, okay. U upon, and this is root 3 u upon 5, okay. So on cancelling this root 3 and 3, we are left with minus 1 upon 5 root 3 tan inverse root 3, and u was our 4 square root of 4 t square minus 3, right? So I will change it in the next step after this. So our format was 1 upon alpha beta tan inverse of alpha upon beta, where alpha beta has to be positive. Okay, so again in the rough, our u was taken, u was 4 square root of 4 t square minus 3, 4 t square minus 3, and t was 1 by x, right? So this is just 4 upon x square minus 3, right? So this changes to square root of 4 minus 3x square divided upon by x. I believe this is the substitution of u in terms of x, right? So on changing this, we have minus 1 by 5 root 3 tan inverse of root 3 upon 5 times u is this, right? So this becomes square root of 4 minus 3x square upon x plus c. So this changes to minus 1 by 5 root 3 tan inverse. If I multiply these two terms together, or let it be as separate in the numerator, okay, root 3 times square root of 4 minus 3x square divided upon 5x. Okay, this is the entire argument plus c. Now this is the answer of the integral. Okay, now we have still a few steps left here. We are given two conditions, f0 equal to 0 and f1 equal to this. Okay, so if we put f0 equal to 0, f0 equal to 0, this implies that on putting value of x equal to 0, this integral changes to 0. Okay, so 0 equal to, on putting x equal to 0 here, you see there is a x term in the denominator, right? So this becomes tan inverse of this constant divided this constant times tan inverse of something by 0, right? So this becomes, first term becomes tan inverse of, since x is in the denominator and this becomes 0, so this is tan inverse of infinity, right? Plus c. So tan inverse infinity is pi by 2, pi by 2, right? Tan inverse of 0 is pi by 2 but oh, sorry, not pi by 2, not pi by 2 directly. This constant is left out, sorry. F0 is equal to 0, right? So this implies that this term will become 10 bars of infinity, but we have this term still left, right? So 0 is equal to minus 1 upon 5 root 3 times 10 inverse of infinity plus c. I think now it is going to be correct. So from here we have 0 equal to minus 1 upon 5 root 3 times pi by 2 plus c. So from here we get c is equal to pi upon, if we multiply these two and take it to the left hand side, this becomes pi upon 10 root 3. Okay, so I believe this is the value of the constant c. Also we are given f of 1 is equal to, I believe it was 1 upon alpha beta times 10 inverse of alpha upon beta, inverse of alpha upon beta, right? So this was our initial expression, right? So if we put value of x equal to 1, we get f of 1. So this constant will remain minus 1 upon 5 root 3 10 inverse of, if we put 1 here, this will become square root of 4 minus 3, right? So this is square root 1. So we are left with root 3 in the numerator and just 5 in the denominator. So this becomes 10 inverse of root 3 upon 5, right? Then we have this plus c, which is plus this value, right? Pi upon 10 root 3. Okay, this is equal to 1 by alpha beta 10 inverse of alpha upon beta. So if from these two terms, if we take 1 upon 5 root 3 common, okay, then we are left with minus 10 inverse of root 3 upon 5 plus, we are left with pi by 2, I believe, right? This is minus 10 inverse and this is pi upon 10 root 3, right? So this is pi by 2 minus 10 inverse x. So this probably becomes cot inverse x. Okay, let me try. So this is 1 upon 5 root 3 times cot inverse of root 3 by 5. So if this is cot inverse x, we can change the right hand side. This is 10 inverse alpha by beta, right? So if we change it to cot inverse, this will become beta upon alpha. Okay, so now we can compare and equate both sides. Okay, so comparing both sides, we get alpha, which is in the denominator. Okay, alpha is 5 and beta will be root 3. Okay, so our question was probably alpha square plus beta square. So this is 5 square plus root 3 whole square. So this is 25 plus 3, which is 28. Okay, so this is the required answer, I believe, 28. Okay, now this was lengthy question, very lengthy. The integral was basically, the pattern is not so difficult up to here, but after that, you know, this calculation is a bit lengthy for this question in particular. Okay, and it requires a lot of, like, you need a lot of patience as well as precision. Okay, so this was a very lengthy question in my opinion. So I believe this is the method I have done. if you know any better methods for solving this type of questions. Okay, usually this is the general method I have shown here and I have discussed it here, but you require a lot of practice for solving these questions in the exam. Okay, especially when you don't have as much time here. I don't know whether to basically start doing this or skip such questions. Okay, if you are, I'll suggest you do, otherwise I might suggest you to skip a few, because otherwise you might get stuck in this question. Okay, so otherwise this is the answer as far as I know, and if there is any mistake in any of my calculations, you can highlight. Okay, or if you know better methods or shorter alternative methods, you can also highlight in the comments. Okay, otherwise I believe this is the required answer. Thank you for watching.